Advanced Financial Modeling, Topic 5, Fixed Income Portfolio Management, Learning Objective number 3. We are going to use convexity to measure the sensitivity of bond price with respect to changes in interest rates. So from the last discussion, what I suggested is that the price-yield relationship of a bond is a convex function curved away from the origin. And the concept of modified duration is an idea of a slope. Actually, it's percent slope, and it tells you roughly the slope of the price-yield relationship at a particular point. And if you use the formula, minus duration times change in yield times the value, it gives you a linear price estimate. So, for example, if initially a bond had a price B0 at yield 0, and the change in yield goes from Y0 to Y1. If I use the duration formula, it would estimate that the value change would be, say, this point here, a linear estimate. However, we know the price-yield relationship is convex, so we know it's probably a little bit higher than that because the function is convex. So what we say is that we have an error because of this convexity. We have a pricing error because of the convexity. And we can adjust or correct the duration estimate by making an adjustment for the convexity of this function. So we're going to talk about the concept of convexity. So the bond price is a convex function of yield. This means that as the yield changes, the bond price will be above the price that you'd estimate it using duration. And what you can do is you can adjust the duration price estimate by an amount that's roughly this or commensurate with the convexity of the function of the bond. Okay, so if we know the price, if we estimate the price of the bond based on duration, we make a convexity adjustment. That adjustment is 1/2 times the change in yield squared times convexity, which we're going to measure in a minute, times the value of the bond. We're going to add this adjustment to that minus duration times change in yield times value and come up with a better estimate of bond price. All right, so how do I get convexity of a bond? Well, if you think of duration as the first derivative of price with respect to yield, convexity, you can think of it as the second derivative. It's how duration's changing. It's how the slope is changing. The actual function is this. I won't get into it, but you could see it's easy to find in the web, derivation of this formula, the second derivative. And luckily, I've written a function for you called convexity, where you put in a bond's coupon, par, maturity, frequency, and discount rate, and it estimates a value of convexity for you, and then you can use that convexity to make a price adjustment based on the curvature of the bond. So let's go back to the spreadsheet we were just working on. Let's calculate the convexity of this bond. I'll put in a function here, look for convexity, and let's go ahead and put the coupon, the par, the maturity, the frequency, and the interest rate, the discount rate, or the R. And you can see this bond has a convexity of 179 units. So what does convexity actually measure? It just measures the curvature. Now notice if I were to make this a 5-year bond, the convexity is only 19. When it's a 10-year bond or 30-year bond, it's 179. So the longer the maturity of the bond, the more curved the function is. If I were to make this a 100-year bond, notice that the convexity went up and actually the graph got more curved. So that is the insight into this convexity number. This bond has convexity of 179, which means that price-yield relationship is very curved. 179 is relatively high. So how could I use this convexity to get a better estimate of this duration price I've estimated before? Well, I calculate something called a convexity adjustment. It's equal to the convexity, anchor it, times change in yield times 1/2. So it's 1/2 times the change in yield squared. I'm sorry, change in yield squared. I need to square that E2. And there it is. That is in percent terms, and then I need to multiply that times the initial bond val. Anchor the bond val. So it's 1/2 times change in yield squared times convexity. Everything's anchored there besides the change in yield, times the initial bond val. So what it's telling me to do is add $88 to the duration estimate. So my duration price estimate was $14.40. I'm going to add that convexity adjustment, curvature adjustment, and now I would have guessed it's worth $15.29, which is a lot closer to the actual bond value. So I'll copy these down, and it's already set to graph. And what you see is this gray line here is the duration plus the convexity adjustment valuation of the bond, which is really close to the actual valuation of the bond. And it's much better than duration estimate, especially for large changes in rates. So that is the concept of convexity. Bonds have a convex price-yield relationship. If you use duration to estimate value, you're going to get a linear estimate, which could be really off for a large change in rates. Now, before we move into the next section, let's talk about why I even do this. If I can always value the bond, why would I use duration plus convexity to come up with a price? And I'll give you the quick answer. When I was working for a big bank, we had thousands, tens of thousands of securities. And during the day, interest rates are changing, so yields are changing. And we're always trying to figure out what is the value change of our total portfolio. Well, we didn't have enough computational resources to value tens of thousands of securities every 5 or 10 or 30 minutes. However, at the end of every night, we could take a weighted average duration and convexity of all the instruments of our portfolio and know that our portfolio worth billions of dollars has a duration of, say, 5 and a convexity of 100. So we can estimate the value change any second just using a simple formula. Minus duration times change in yield plus 1/2 change in yield squared times convexity. So that's the real advantage. And it's also just a nice shorthand to know, well, which of these bonds is more sensitive or riskier than this other bond? Well, what are their durations and convexities? So that gives you an idea of why I actually use duration and convexity in the real world. In the next topic, we'll use Excel's built-in functions.